Hello, dear students. Today we are going to start quadratics for A levels. This is lesson number 1 for quadratics. As you know, quadratic expression is of the form y is equal to ax square plus bx plus c, where a is not equal to 0. Because if this a is 0, then this equation will be simply reduced to y is equal to bx plus c, which is basically a linear equation. So a cannot be 0. It means a can either be positive or it can be negative. So we are going to discuss the graph of this quadratic expression in both these cases. When a is positive, I will take an example. Y is equal to x square minus 5x plus 6. Here a is basically 1, which is positive. So when a is positive and I want to find the roots of this quadratic polynomial, I will factorize this by putting it equal to 0. And ultimately I get two factors. From there I will get x is equal to 3 and x is equal to 2. These are 2 points at which the graph crosses x-axis. See over here, this is 2 and this is 3. I have drawn the exact graph of this quadratic polynomial, and you can see that it comes from above the x-axis, crosses the x-axis at x is equal to 2, then goes down, reaches its minimum value, then comes up again, crosses the x-axis again at x is equal to 3 and goes up. This point at which it turns back is called vertex of the parabola. Parabola is the graph of any quadratic polynomial. Coordinate of vertex are minus b over 2a and c minus b square over 4a, where this c minus b square over 4a is minimum value of this polynomial, y coordinate of vertex. This graph is very important. We will have to look into the graphs of quadratic polynomial when solving many questions, especially quadratic inequalities. If you carefully observe, when coefficient of x square a is positive, graph opens upward, like it comes from above, comes down, crosses x-axis, goes down and then turns back, comes up again, crosses the x-axis at the second root and then goes up and never to return. It means before crossing the x-axis it is positive and then it is negative. When it turns back and crosses x-axis again, it is again positive. So any quadratic polynomial will be positive. If a is positive, it will be positive before crossing the x-axis at the first root and after crossing the x-axis at the second root, and between these two roots it will be negative. This is very important to this concept we will use in solving the quadratic equation. Let us discuss the second case now. When a is negative, coefficient of x square is negative. I will take an example. Y is equal to 5x minus x square minus 6. To solve it and to find its root, I will put this equal to 0, and ultimately I will get 0 is equal to x square minus 5x plus 6, which you can observe that it is actually the same equation, and ultimately we will get the same two values of x, which are 2 and 3. What is the difference now? We got the same two roots, 2 and 3. Difference is this, that this time graph is basically opening downwards. It opens downward. It comes from below the x-axis, crosses the x-axis at its first root, and then goes down to cross x-axis again and goes down, never to return. This time vertex is above x-axis, but its coordinates will be the same. Because a is a negative, so ultimately the value of minus b over 2a will be different, but to calculate the value of x coordinate of vertex, we will use the same formula, and same formula for y value, which will be positive in this case, and this will be maximum value now. And also you can see from minus infinity to first root 2, and then from 3 to second root to infinity, this y is negative. This is below x-axis, but between the roots, value of y is positive. So 5x minus x square minus 6 will be positive between these two roots and negative beyond these roots. So these were two cases of the quadratic polynomial, very important to solve quadratic inequality. We have to understand its graph. Graph opens upward when a is positive. It opens downward when a is negative. It is negative between the roots and in the first case, and it is positive between the roots in the second case. In the first case, from infinity minus negative infinity to 2 first root, and then second root to infinity, it is positive, and in the second case the situation is vice versa. So these were two important graphs which we need to understand when we have to answer the real-time exam-based questions. Let us move forward and discuss the roots of quadratic equations. As we have already learned the formula, quadratic formula to solve the quadratic equation, and this formula is x is equal to minus b plus minus b square minus 4ac square root over 2a. This factor is very important. It is called discriminant. You know that when it is negative, both roots are minus b over 2a. And when it is positive, both roots are different and real. But when it is negative, when it is zero, roots are equal. When it is negative, roots will be imaginary. Let us practically discuss these three cases. I am taking the example x square plus 4x plus 4. This is the quadratic polynomial. I am putting it equal to 0, and ultimately by factorization I will get x plus 2 into x plus 2. So its both roots are minus 2 and minus 2. This is minus 2. This is the graph. Coefficient of x square was positive. Graph is opening upward. But since both factors are same, so its roots are equal, and you can see that graph comes from above x-axis, touches the x-axis and goes up. So its minimum value is 0. It is tangent to x-axis. It does not cross x-axis. So when discriminant b square minus 4ac is 0, the graph of polynomial is tangent to x-axis. In this case, b was 4, 4 square minus 4 into a was 1, and c was 4, which is equal to 16 minus 16, 0. This is the second case when discriminant is positive. I am taking the example, graph is in front of you. I am taking the example x square minus x minus 12. By putting it equal to 0, I will get x. I am solving it x square minus 4x plus 3x minus 12. And when I will factorize this, I will get ultimately the two factors. So one root is minus 3, second root is 4. Graph will be like this. Rough graph will be like this. This is first root minus 3 and second root is 4. And you can see that graph is intersecting the x-axis at two different points. So for that, our necessary and sufficient condition will be this discriminant is positive. When this discriminant is negative, let us discuss the third case. When this discriminant is negative, for example, this discriminant is the equation is x square plus x plus 1 is equal to 0. A is equal to 1, B is equal to 1, C is equal to 1, and discriminant will be B square minus 4 into A into C. Graph will not even touch the x-axis. There are no real roots. To summarize today's lesson, there are two different shapes of the parabola. If coefficient of x square is positive, graph opens upward. If coefficient of x square is negative, graph opens downward. In the first case, we have the minimum value but no maximum value. In the second case, we have maximum value but no minimum value. In the first case, and in both the cases, coordinates of vertex are minus b over 2a and c minus b square over 4a. Then we discuss three cases. In the first case, when discriminant is 0, the graph intersects the x-axis at only one point. That is, quadratic equation will have only one answer when discriminant is 0. It will have two different real answers when if discriminant will be positive, and it will have no answer, no solution when discriminant is negative. That is all for the first lecture of today. Hopefully it would be very beneficial for you. We will, inshallah, in next lecture we will study about the quadratic inequalities, solving the quadratic inequality and solution of a linear and quadratic equation, and ultimately we will move towards solving the past year exams question. Please do subscribe this channel so that you are timely intimated about our new videos. Thanks for watching. Allah Hafiz.